Hello, my name is Andy Lazor. I'm a water quality specialist with the University of Maryland Extension, and I'm going to be talking to you today about drinking water treatment. So a couple of the major topics will be water contamination, various water sources, and knowing if treatment is actually necessary, testing your private water well, treatment devices, and then other considerations for treatment. So it's important to note that much of our activities have potential to add contaminants to our water. So whether it be industry, agriculture, our recreation, our automobiles, the personal care products that we use at home, animal production, all of these things potentially can add contaminants not only to our land, but also to our surface waters. And then anything on land can infiltrate into the soil and then down into groundwater. And then a lot of our groundwater and streams and rivers are connected. So again, a lot of activities that can potentially add contaminants to our water. It's also important to note that in certain areas, there is natural contaminants in our geology. In Maryland, arsenic, radium, and radon are three examples. And then we also have the influence of brackish water intrusion from both the Chesapeake Bay and the coastal bay. So when we think about treatment, it's really important to note that you really need to understand your water. Get to know your water. Then with that information, you can determine whether or not treatment is necessary. If you're on a public source and you get a water bill every month, that water is regulated by EPA and then also the appropriate state agency. And that water is tested on a regular basis for 90 some odd contaminants. And EPA mandates that public utilities provide an annual report to all the consumers or customers. It's called the Consumer Confidence Report. And then if you do find an issue with your water, particularly if you have a private well, it's ultimately your responsibility because it's not regulated. You're responsible for testing your water and also maintaining and taking care of your well. So if you did find a source of contamination with a private well, you'd want to first identify and eliminate that source of contamination, whatever that may be. So with public water sources, again, as I said, they're regulated by EPA through the Safe Drinking Water Act. And then each state has an agency that's delegated to maintain and regulate drinking water. In the case of Maryland, that's the Maryland Department of Environment. So under the EPA, there are what's called drinking water standards, regulations, and they test on a continual basis for 90 contaminants. And some states require additional analyses. These include disinfectants, which are, for example, chlorine is used to kill off bacteria. And then those disinfection chemicals can break down and are produced byproducts. There's inorganic chemicals, microorganisms, bacteria, viruses, organic chemicals, and even radionuclides. So here's an example. Here's actually the complete list, current list in 2020 of what is being tested by public utilities. So you have the disinfectants, you have the various disinfectant byproducts, you have many of the inorganic chemicals that we're familiar with, arsenic, barium, fluoride, lead, copper, mercury, things like that. We have the microorganisms. These are the common bacteria species that can be seen, can be found in particularly in surface water sources. Then there's the suite of radionuclides, And then there's a whole long list of industrial and agricultural organic chemicals, as you can see here. So in that public water treatment, there's several steps that water goes through, dependent upon what type of source water. And that's important to note that public utilities use both surface water, that could be a reservoir, it could be river water, or they use wells. In any case, they treat the water by pre-chlorination. That again is to kill off bacteria. Then they go through several steps of settling, fluctuating, coagulating the solids to remove all that organic material that may be coming from the source. They filter that through several different types of processes. Then they go ahead and may add fluoride, which has been added as a means of reducing tooth decay. There is new work going on, research that is suggesting that fluoride may actually have some health concerns, and so some utilities are electing not to add fluoride, especially since dental care has improved greatly in the United States, and that many of the dental products already have fluoride in it. Then there's a post-chlorination process. This is again to ensure that the water leaving the treatment facility is free of bacterial contamination. Then before it leaves, it goes through a corrosion control treatment. And they use different compounds here, various phosphates, some silicates, and also some carbonate adjusters, such as lime, for example. And this is to be sure that the water is not corrosive. So corrosive water is the cause of many of the issues that we've seen with lead and copper, for example. So here's an example of a consumer confidence report. Again, this is mandated to be supplied to customers on an annual basis. If you haven't seen one, you can contact your utility. Oftentimes these are all online as well. A wealth of information. Here's an example of one. Gives you all the specific compounds and the test results they've seen, and also tells you if there's been any either violation or if it's exceeding EPAs. Obviously, if they test it, the water, and it's found to be at an elevated level, they're going to be incorporating treatment to keep these contaminants well within the EPA guidelines. Again, a little bit more information looking at some of the disinfectant byproducts, for example. If you're on a private well, as I said, you are responsible for doing your water quality testing since it's not regulated. And this is what is recommended on an annual basis to test for coliform, bacteria, E. coli, and nitrates. These are indicators of contamination from animal waste, possibly fertilizers, in the case of nitrates. If you test these annually, since groundwater does move, albeit very slowly, it's important to test annually for at least these three. And if you were to get a positive result, then you'd want to determine, what is the source of that? Is it a septic tank connection issue? Is it, animal waste? Is there some damage to your wellhead, for example? So again, you'd want to test for this annually, and then test for these other contaminants on about a 3-year cycle. That's chloride, pH, lead, copper, manganese, hardness, total dissolved solids, sulfates. And then if you have any naturally occurring or local land uses that may be presenting some possible contamination. Your local health department has a wealth of information on this. It's a great resource. They can tell you if there's any typical land issues or naturally occurring contaminants in your area. So please contact your health department. You can also test your well for specific issues. If you're seeing stainage, whether it's orange or black, that would be an indication of iron and manganese, for example. If you're getting white scale built up on your dishes, or it's very difficult to get soap to lather up, that may be an indication of high hardness. Certainly if you're getting a salty taste, that would be indication of chlorides in your water. And if you were to see any blue stains, or you have pinhole leaks in your copper pipe, that's an indication that you have corrosive water potentially. And if you do, you definitely want to test for pH, copper, and lead. The good news is that for home water systems, there are many, many types of filters out there that can treat water for a whole host of contaminants, as you can see on this chart. The ones in red are those that are present health concerns, and the other two, hard water and iron and manganese, is actually an aesthetic issue more than it is a health hazard. But as you can see, there's several types of filters, and we'll walk through each of these in just a minute. If you test your well water and it was to come back and you had one or two of these contaminants, you definitely want to determine if one filter could treat for both contaminants. Sometimes that's not the case, and you might have to have two different types of filters or more, again, dependent upon your water quality. So when we look at treatment systems, there's two basic types. There's point of entry, or whole house treatment. And again, that's just that. It's going to take the water as it comes from the well and run it through the filter, and it's going to supply your entire house. The other option is what's called point of use. That's right there at the, say, for example, your kitchen faucet. If that's what you use for your drinking and your cooking purposes, you could put a point of use filter either directly onto the faucet or under the sink, for example. Here's some examples of point of use filters, things that you can put on the faucet, filters that go into your refrigerator, or in the case on the left, there's an under the sink RO, or reverse osmosis filter. The important thing with any of these filters is be sure that you see an independent certification label. And here's some examples here: NSF, UL, and the Water Quality Association. Very important, because water filters are not regulated by any government entity. And so this is a third party, independent type of certification, is very important. And when you buy a filter, it'll have on the label one of these or more of these certification emblems, but it also will describe to you what those filters will filter out, what contaminants and what percent of contaminant removal that they provide. EPA has some information online about this. They have a wealth of information, and it talks about point of use filters. So you can check that out. And again, here's an example where the label will specifically tell you what it's removing, and again, at what percent removal. A wealth of information, very valuable. So going through the different types of filters, one common one is a sediment filter, and it's basically trapping out any sort of suspended particles, whether it be sand or clay, or even rust or oxidized iron, for example. These sediment filters are available as point of entry or point of use. The issue with any filter is eventually they can get filled or clog, and so they need to be replaced. And dependent upon the sediment load that you have in your water, these filters can get clogged fairly quickly. And so in some cases, if you have a high sediment load, you'd probably want to have, you could have several stages of these sediment filters, or larger sediment filters that would enable the water to be treated, and you wouldn't have to change the filter out as often. If you do not change the filter, what can happen is not only will it clog, but you can actually get bacterial buildup over time. And once a filter is saturated and it is contained the contaminant that it's designed for, and it's not changed, you're actually getting release of that contaminant into your water. So again, important to change your filters as recommended, or if you note, in the case of a sediment filter, if you note any water reduction in your flow rate, that's probably an indication that your filter is needing to be replaced. Activated carbon filter. If you've ever had an aquarium, you're probably familiar with this, that there's carbon that's used to filter out the aquarium water. In this case, obviously, it's used for drinking water. And these typically are used to remove any sort of unpleasant taste or odor. Chlorine, for example, even some of the pesticides, for example. If you look at the common refrigerator filter, oftentimes it'll remove chlorine and some pesticides. You also get some heavy metal removal. Again, it depends upon the type of filter. These are available both for point of use under the sink or at your faucet, but also whole house or POE. Again, these things need to be changed on a regular basis, and you have to follow the manufacturer's recommendation, because the carbon will get saturated essentially over time with various contaminants, and then it will no longer function. And then there's different types of media filters. For example, this is again used to trap solids. This diagram shows different types of compounds that are used: quartz, sand, and different types of coal products that are used. Again, it is designed to trap out solids. Solids get trapped in between these different types of particles. This is a whole house or POE type of device. And then it's usually set up on an automatic backwash to where water will flush the system and then release the sediments from the media particles. You have acid neutralizing filters. These are used typically if you have low pH. And low pH is one of the causes for water corrosivity. And so these filters use a neutralizing media, whether it's calcium carbonate or marble chips, for example. And then this media needs to be replenished periodically. And again, that depends upon the severity or how low your pH is and how much water you're actually treating. But when you're using a neutralizing filter, it's important to note that it likely will increase your water hardness, which is calcium and magnesium. So if you're using calcium carbonate or marble chips, which has a lot of calcium in it, you're going to be adding calcium to your water. Calcium is an important necessary nutrient, and it's not a health hazard, other than it can lead to increased hardness. You may get a buildup of scale, either in your water heater or little deposits on your dishes, for example. And if you do have hardness, you're going to typically look at whether or not a water softener makes sense. If you have very hard water to where you're getting a lot of scale buildup, then one of your options is to use an ion exchange water softener. And the important thing to note here with this type of treatment system is that you're basically replacing the calcium and magnesium ions with sodium. And so using one of these, you're increasing the sodium level of your drinking water. And if you're on a low sodium diet, then this may not be the right process for you to consider. There is some new technology coming out, albeit slow. It's a saltless water conditioner, which is basically a little different. It uses electricity, but there's not a lot of companies selling this equipment. So, we anticipate that we'll see more and more of this, option for conditioning and remediating hardness. These systems have to be periodically not only adding salt to your system, but then it's continually backwashed as the resin gets clogged up with sodium particles. Typically, these are used if your water is hard. 120 parts per million, milligrams per liter, same thing. And again, it does require additional salt on a periodic basis. Again, the frequency of adding salt will depend upon how much water is being treated and the size of your system. One of the things you need to consider is with a water softener is that the backwash is a significant source of chloride. And so you need to think about where is that water being discharged. If you're on a septic system, there are certain types of advanced treatment systems that do not want the sodium and the chloride being discharged into that system. The other thing to note about chloride is that it basically, once you add it to the soil, it basically goes straight down to the groundwater. It's not bound in soil like some other contaminants. So again, you need to think about that. In some cases, water softeners will be used to treat iron or manganese as well. A real common filter is reverse osmosis and RO. And basically here, it's forcing water through a very, very small membrane. But RO is very effective and removes quite a number of contaminants. And you can have either a whole house unit or in the case on the left, you can see kind of an under the sink type of RO system. Again, numerous manufacturers up there. What you'll notice is that there are oftentimes pre-filters and maybe even a post-filter after the actual RO membrane treatment. So again, it might be a series of different types of filters in order for the system to operate at maximum efficiency. One of the important things to note about RO is they have a lot of water usage. So they use anywhere from 1 to 4 gallons of water to treat 1 gallon itself. So again, as the system's going to have a lot of wastewater, and you need to consider what you're going to do with that wastewater. Okay, the membrane can foul, particularly if you have hard water. And as I mentioned, there's pre-sediment and carbon filters typically used, incorporated with systems that you want. And the membrane might need to be replaced periodically. Again, depending upon the amount that's being treated. Now for bacterial treatment, ultraviolet light or UV disinfection is a common treatment system. And it uses the ultraviolet spectra of light to kill off bacteria. And this is effective if, as long as your total coliform and E. coli concentrations are below a certain level. If you have a very high concentration of bacteria, you'll probably have to look at some other type of treatment system, whether that's a automatic chlorination system or some sort of distillation process. But typically, a UV system is very effective. The water needs to be relatively clear, very clear actually, for the light to penetrate through all the water. And the bulbs probably need to be replaced every 9 to 12 months. This is a tool, an online tool put out by Penn State Extension. It's a great tool, a drinking water interpretation tool. So when you get your test results back from the lab, you can simply type in your results in these various boxes, and it will put out a report that will tell you what those results mean, but then also will tell you what sort of treatment system is recommended. This particular slide here shows I populated the online tool with just some made up numbers here, but you can see the example of, what it's telling you. E. coli in this case was 0, and it's basically telling you, yes, it meets standards. The arsenic level was elevated, and this tells you where arsenic comes from. Tells you that it exceeds the standards, and it also tells you what types of filters can be used, reverse osmosis, for example. And then again, a couple of other examples. Here's one, hardness. Again, I put in 180, which is hard water. This is, again, not a health hazard. It's more of an aesthetic issue, but it does, again, tell you information about where it comes from, some of the symptoms that you might be noticing, but it also tells you, how to treat that. So it's, again, a great resource for you to consider. So building on considerations about treatment, besides knowing your water, okay, it's important to note that when shopping or deciding what sort of water treatment, there's a lot of choices out there. They're not regulated, as I mentioned earlier. And if you have more than one water quality contaminant, then you may have to look at more than one type of filter. We recommend that you only buy what is needed. There are some systems that come with various components, but what you want to know is that whatever treatment system you buy, it has to be maintained. Not only do you have that upfront cost, but it has to be maintained. So if it has multiple filters, you're going to have to be exchanging or replacing multiple filters. So quick rule of thumb, only buy what you need, okay? And you only know what you need after you test your water. The other thing with some types of systems, particularly those that with backwash, periodic backwash, is consider what you're going to do with that waste stream, that backwash water. And it does have impact on septic systems potentially. And if you then opt to go with surface discharge, and it's a water softener, just know that chloride can kill vegetation and impact groundwater quality. So it's a good idea to check out different types of filters, multiple companies, and get some bids and references. Be sure that you're using certified filters. Definitely follow the manufacturer maintenance schedule. Again, if you're not changing filters, that filter is going to get clogged. You may get reduced flow, but the contaminant can be released into your drinking water. And then the other thing is be sure that you're following the manufacturer's recommendations on how to dispose of those filters properly. Because again, if you're filtering out a contaminant and you're throwing that into the trash, you're adding contamination to the trash, but there may be another option for that. Your local county may have a service that will actually take filters, for example. So again, just some tips for you to consider before you actually purchase the water treatment, to make sure that you're getting what you need and that you understand what it takes to not only operate, but also to maintain the water treatment system. So here's several resources that you can tap into. Certainly EPA has a wealth of information. And if you're not, from Maryland, you can certainly look at your state agency that's responsible for regulating water quality, and also check out your local health department. They're a great resource for information about particularly wells and water, what to test for, where to go to get your water tested, things like that. So thank you for your time.